Hello and welcome to Hot in Math. In this edition of Hot in Math, we're going to talk about graphing and writing equations of circles. All right, so let's get started. Now we're going to back up a little bit. Well, we're going to start with the equation of the circle, and then I'm going to go through the derivation of the circle with you. All right, so I'm going to go ahead and give this to you straight away. There are two forms of circles that I want to give to you today. The first one is standard form for an equation of a circle. X minus h squared plus y minus k squared is equal to r squared, where hk is the center of the circle and r is the radius. So now we're going to go ahead and derive that formula. And first I want you to remember the area of a circle is pi r squared. Circumference of a circle is pi d, or 2 pi r. And the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. We're going to use that distance formula in order to derive the equation of the circle. So Pythagoras did us a great service. He found that the sum of the squares of the legs of a hypotenuse equals the square of the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. We use that to find the length of the hypotenuse as a distance between 2 points, and then we're going to go ahead and translate that into an equation for a circle, all from one theorem. All right, so circle is a set of all points that are equidistant from a fixed point called the center. Now you need to remember for all of the conics that we're going to cover, you need to remember what the definitions are that'll help you to find the equation. Remember what's happening in that particular conic. So this is the set of all points that are equidistant from a fixed point called the center. Means that these points along the outside, I guess the circumference of the circle is the circle. The points inside of the circle are not the circle, and the points outside of the circle are not the circle. It's a set of all points that are equidistant from a fixed point called the center, and that's the circle. So remember, the operative word here is equidistant, same distance, and again we're going to use the distance formula in order to figure out the formula for the circle. All right, so the first thing I want you to do is I want you to find the distance from the center 0, 0 to a point on the circle 3, 4. I'm going to pause here while you take care of that and come back. All right, so you should use a distance formula, and I want you to use a distance formula for all of these equations. You're going to find out that the distance from 0, 0 to 3, 4 is 5 units. All right, so now I'm going to ask you, what is the distance from center A to B? I'm sorry, from the center to A or B, and you should pretty quickly figure out the distance is going to be the same as that which we just discovered from 0, 0 to 3, 4. So the distance is 5 to either A or B because the radius length is the same. All right, so now we're going to assume that point A has a value of x comma 3, and I want you to figure out what the value is for x, given that the radius remains the same at 5. I'm going to pause here while you figure that out. All right, you should get negative 4 comma 3. Now just be careful when you calculate this. You'll end up with x squared is equal to 16. And remember, when you take the square root of a squared number, you're going to add plus or minus to both sides. You'll get x is equal to potentially plus or minus 4. You'll realize that A is in the second quadrant. You'll realize that x is negative in the second quadrant, so you'll come up with a value of negative 4. All right, so now we're going to calculate the value for y for B. If the point B is negative 1y, so I want you to use the distance formula and solve for y. I'm going to pause here. All right, so y ends up being negative 2 root 6. So negative 1, negative 2 root 6 ends up being your coordinate for B. All right, moving on. So now I'm going to shift the center off the origin, 0, 0. Center is now 2, 2. Find the distance to A if A is 5, 6. So I want you to use a distance formula again to calculate that value. All right, so you're going to end up with 5 units again for the distance from the center to the circle. All right, center is 2, 2. I want you to find the equation of the distance to B if B is xy now. I'm going to pause here while you figure that out. All right, you're going to end up with the square root of x minus 2 squared plus y minus 2 squared is equal to 5. As you can see, we're kind of moving along the way to getting the formula for the equation, standard equation for a circle. Now we have the radical sign. All we need to do now is square both sides and we'll end up with a formula. All right, so let's finish this up. So we are going to, or you're going to pretend that HK, this is an H, K is the center, XY is a point on the circle. Now you're going to give me the distance from XY to HK. So again, this could be any XY to any HK, so to speak, where HK is fixed, but XY will change as it moves around the circle. So I'm going to pause here while you figure that out. All right, so you get the square root of x minus h squared plus y minus k squared. And that's going to be equal to your radius. That's the distance. All right, so we end up with an equation of a circle x minus h squared plus y minus k squared is equal to r squared. Now I want you to take the equation in the bottom left of the page, x minus 3 squared plus y minus 3 squared is equal to 16. I want you to graph that, and then I want you to provide 4 points outside of the center. So 4 points on the circle, 4 coordinates, and I want you to provide the values for those coordinates. I'm going to pause here while you graph. All right, this is my attempt at using my cursor for my notepad and drawing a circle. I know it's not very accurate. But here's my circle centered at 3, 3. I've identified 4 points, moving up 4 units, down 4 units, left 4 units, right 4 units because the radius is 4. I end up with 3, 7, 7, 3, 3, negative 1, negative 1, 3 as points on the circle. All right, so now I want you to take a center of 2, negative 2, and a point on the circle 7, negative 7. I want you to write an equation for that circle. I'm going to pause here while you do that. All right, so you should come up with, I just gave there's a multiple choice. X minus 2 squared plus y plus 2 squared is equal to 50. Okay, moving on, I'm going to give you some classwork to do or online YouTube work to do. So go ahead and solve each of these 4 problems, then we'll come back and take a look. I'm going to pause here while you do this. Okay, so first one, x minus 4 squared plus y minus 3 squared is equal to 4. So remember, this is the radius squared. Problem number 2, we're going to find the midpoint. 8 plus 0 over 2, 0 plus 6 over 2 leaves me with a midpoint of 4, 3. Midpoint is the center. Distance from 4, 3 to 8, 0 is going to be the square root of 25, which is 5. And I have my center at 4, 3. X minus 4 squared plus y minus 3 squared is equal to r squared 25. That's problem number 2. Problem number 3, I'm going to use a distance formula to figure out that the distance from 2, 3 to 5, 6 is 3 root 2. 3 root 2 squared is 18. I have the center already, so all I have to do is figure out the length of the radius. So x minus 2 squared plus y minus 3 squared is equal to 18. And the last question, it's helpful for you to draw a line. X is equal to 4. You know it's tangent to the circle with a center of negative 3, 1, which means it touches the circle in one spot. You know that the radius is perpendicular to the tangent line at that one point. So you can measure out the distance of the radius. It's from the center horizontally to the circle itself is going to be 7 units. So from negative 3, 1 to the line x is equal to 4 at 4, 1 is going to be 7 units. So you have the radius of 7. 7 squared is 49. You're already given the center at 3, 1. So x plus 3 squared plus y minus 1 squared is equal to 49. All right, so next thing that I want you to do is I want you to be able to take general conic form, which is the second form that I want to show to you, and rewrite that form in standard form. So we're going to go through the process again of completing the square. And so let's take the bottom equation for a circle in general conic form. Let's convert it to standard form, because standard form gives us the center and the radius, which is essentially what we need in order to graph the circle and identify the components of it. General conic form is not as useful. All right, so we're going to complete the square. We're going to group the like terms, x squared minus 30x. I'm going to place a placeholder for the c values for both x and y. Also, it's my preference that I move the constant to the right-hand side of the equation. So I'm going to subtract 234 from both sides. And then I'm going to complete the square for both. B over 2 squared, so 30 over 2, 15 squared is 225. I added my value of 225 here. 10 divided by 2 squared is 25, so I completed the value for c for both the trinomial for x and y. And then I'm going to rewrite that trinomial as a squared binomial, and that's what we were after originally by completing the square, and end up with x minus 15 squared plus y plus 5 squared is equal to 16. And so remember, when you have a balance, which is what we had here in the first line, and we added 225 and 25 to the left-hand side of the equation, we also have to add it to the right-hand side of the equation. So adding 250 to negative 234 leaves us with a balance of 16. 16 is the r squared value. So now we see that we've converted general conic form of this equation by completing the squared binomials. We end up with a center of 15, negative 5 with a radius of 4. All right, I'm going to give you one more problem. Let's just do number 1. I might give you the answer to both. Let's just work on number 1. And then I'm going to pause here. You come back and show me what your answer is. Okay, so the first one, I'm going to group the like terms, move the constant to the right-hand side, complete the square, create a squared binomial from the trinomial. You can see that my center is 1, 4 with a radius of 1. So let's see if I've also worked out the second problem. I believe I have. Again, moving constant to the right-hand side of the equation, creating a space for c, completing the square, b over 2 squared, rewriting the trinomial as a squared binomial. I end up with x minus 2 squared plus y plus 3 squared is equal to 9. So center 2, negative 3 with a radius of 3. All right, that's it for this edition of Hot in Math. Please come and join us next time. I believe we're going to talk about ellipses in chapter 6.3.